Okay, ladies and gentlemen, welcome to another video solution. This is from section 1.3, question 8. It's a thinking question. The answer should be in the back of the book, but won't likely have the whole solution. So here we go. 2 dice are thrown and the sum is recorded. We've seen the outcome chart for this. It's 6 by 6, 36 different outcomes. Part A, if 20 trials are carried out, is it possible for the statistical probabilities of each value to be equal to the corresponding theoretical probabilities? The new term there we haven't seen, statistical probabilities. That is synonymous with experimental probabilities. So when it says statistical, it's just another way of saying, is it possible for the experimental probabilities to be equal to the theoretical probabilities? So I'm going to go ahead and draw the outcome chart. Here we go. Do an outcome chart nice and big here. Okay, so here's our outcome table. 36 possible outcomes when you roll 2 dice. The lowest sum would be 2 and the largest sum would be 12. So what I'm going to do is I'm going to create another table which shows all the different possible sums. And then we have to consider the number of ways that those can occur. So n of x. And there's one way that 2 or 12 can occur, and 2 ways for 3 or 11, 3 ways for 4 or 10, 4 ways for 5 or 9, 5 ways for 6 or 8, or sum of 7 is the most commonly occurring outcome, 6 out of 36 ways. So let's just think now, what would these look like if they were probabilities and if they were reduced? I mean, 1 out of 36 can't be reduced, right? 2 out of 36 can reduce to 1 over 18. 3 over 36 reduces to 1/12. 4 over 36 reduces to 1/9. Oops. 5 over 36 doesn't reduce. 6 over 36 reduces to 1/6, and then we just have a repeat of the same probabilities. So the thing is that none of those really correspond to probabilities out of 20. So you couldn't have, like if you had anything out of 20, we're talking about statistical probabilities out of 20 trials, then all of those probabilities are either going to be 5%, 10%, 15, 20, something in that range, or 1 out of 20, 2 out of 20, 3 out of 20, and none of those can be equal to these values. None of these can be equivalent to a fraction out of 20. So, explain why or why not. No. None of the theoretical probabilities can be written as a fraction of 20. So they can't be equivalent. So no, if you can read my handwriting, good for you. No, none of the theoretical probabilities can be written as a fraction of 20. So with 20 trials, the experimental probabilities will all be different. Let's see now. Question B says, what's the minimum number of trials necessary for statistical and theoretical probability values to perfectly agree in this case? justify your answer. I mean, for all of them to agree, I think you would have to have 36. In fact, I'm not sure if that's the minimum or the only number of trials. Well, I suppose it's possible that you could have 72 trials and that it might work out, but if you're going to guarantee that the theoretical and experimental probabilities agree, I would say that 36 would be the only way that it could happen. So, 36 trials. And then there's still no guarantee that they will perfectly agree, because, you might just get, well, they probably won't agree, but it is the minimum number where there's the possibility of them agreeing. It's possible that you might get a sum of 2 once and a sum of 3 twice and a sum of 4 3 times. It would be highly, highly unlikely, but it is possible. And that's the lowest number where it's even possible. Hope this helps, and well, tune in next time. We'll try another video. Thanks, bye.